Hello everyone, and welcome back to a new session on update and enhancement of STAAD.Pro CONNECT Edition. I am Surajit Ghosh, and in this video, I will talk about the latest features of V22 Update 11, which has been released in mid-August. Though there is no new enhancement except few OpenSTAAD function and integrated module, still this version is important as this is another bug fix built after Update 10 with several major fixes and performance improvement. Do you know generated plate mesh with parametric model is now more optimized and has better connectivity with other entities? I'll cover this, but before that, few generic information. In Update 11, there are more than 200 updates which are reported in the revision history file. We can search and get information related to any topic like updates related to IS800. Also, we can copy it to Excel, categorize and filter it. Among these, few are major updates which can change the final result, and this will be covered today. You can check rest of the minor improvements from the revision history file. Link is provided in the description. I will start with the updates in Analysis and Design module, which are the most important one. Then cover the updates in the Analytical and Physical Modeler, enhancement in the OpenSTAAD library, and finally discuss about the improvement in the interconnected modules like RAM connection and RCDC. Let's start with the updates in Analysis and Design engine. In this version, there are few updates related to Indian code, both steel and concrete, and I want to start with a fix related to IS800 2007. For any steel structure under clause 4.4.2 and 3, code suggests to use first order elastic analysis neglecting any second order effect, and additional moment due to deformation is considered using a moment amplification factor. This factor KYKZ is calculated under clause 9.3.2.2 and used in the axial compression plus bending interaction check. This method is valid till the factors are less than 1.4, but when it is greater than 1.4, proper second order analysis like P delta is required, where the second order deformation are considered in the analysis result. A warning is also reported in the output file related to this. By the way, these are not effective length factor. I have published a detailed video on moment amplification factor and how this is used for member design. You can check that. Instead, when a second order P delta analysis is performed, KYKZ value is considered as 1 as moment is already amplified during analysis. Additional moment amplification during design is not required, but when P delta kg analysis is used, this logic was not followed in the earlier version. Though second order effects are included in the analysis result, still calculated moment amplification factors are considered during interaction check, so moment is amplified twice, which is conservative. In Update 11, this issue has been fixed, and if P delta or P delta kg analysis is performed, KYKZ value is considered as 1. This fix will affect only the compression plus bending interaction ratio. There is another minor fix related to section selection using select or select optimized command. In older version of STAAD, when iterative section selection is performed for a member with both strength and service load envelope, program was unable to select proper section size. Now this issue has been rectified for IS800 2007, AISC 360, New Zealand and Canadian code, and program suggests the most optimum section considering both strength and deflection criteria. For cold form section design as per IS 801, there is one update. For very thin profile with angle, channel with or without lips and head profile, correct effective buckling width and neutral axis are now considered for design. For IS 1893 2016, there is a minor modification related to cracked section property. Under clause 6.4.3, code suggests to consider 70% inertia value for concrete column and 35% inertia for concrete beam. This reduced property can be considered during seismic analysis using code-specific property reduction factor for IS 1893-2016 code by specifying correct reduction factor. But for dynamic analysis, when the mass model is defined under first dynamic load case, this reduction was not considered correctly, and program encounters an error during analysis. This has been fixed, and whether the mass model is defined under a mass reference load case or first dynamic load case, reduced properties are considered for seismic analysis. Do you know we can now auto-generate mass model from gravity load case using a mass model generator? This feature was included in Update 9. For batch mode of concrete design as per IS 13920 and IS456, there are few updates. For column joint strain check as per IS 13920-2016, there was a problem related to memory allocation. Also, several joint conditions such as an inactive member connected at that joint was not considered properly. These issues have been fixed now, and if we perform concrete design using batch mode, then joint check results will be more accurate. For IS 456 code, there is one change related to column design. When a column is subjected to tensile force, minimum percentage of reinforcement should be based on the required area of the column, not the actual provided area. In older version, reinforcement percentage was based on the provided area. This has been corrected. That's all about Indian code. For AISC 360, there is no major update. One minor fix related to torsion design using DG9. For Eurocode, there are few important updates. Design of wave taper section using EC3 code was implemented in Update 10, but there was a problem with design results as correct section properties were not considered for design. This problem and another issue with slenderness ratio calculation for single angle section has been fixed, and now correct LEG parameter is considered for design. By the way, there are several fixes related to timber design using Eurocode 5 and for steel design as per Australian code. A problem related to slenderness ratio calculation using main and T-main parameter. Axial and bending capacity check for slender RHS and SHS section has been corrected. Apart from this, few new warnings are introduced for physical member design, few minor change for Japanese and Canadian code. Details are available in the revision history file. In the analytical modeler, there are several updates, and I want to start with a major improvement related to plate mesh generation. Finite element is often required to model a reinforced concrete wall or retaining wall, float diaphragm, mat foundation, or other complicated structure which require a detailed analysis. In this modeling mode, we can generate a plate mesh in different ways, use infill plate option to generate a single plate, or plate mesh and generate mesh option to create a meshed surface with user-defined element size. But both this approach is very basic and generates several modeling issues like beam to plate or plate to plate connectivity or work plate condition. For generation of FEM for a complex region or a zone which is already connected with another meshed surface, these methods are not suitable. There is an advanced method, parametric model option, which can generate a plate mesh based on different boundary condition. This method can identify any existing node or member within the boundary as density point and density line and establish proper connection with any interconnected surface during mesh generation. For example, consider this building where I have generated a plate mesh at each floor using parametric model. All these plates are generated properly without any connectivity problem with other beam or node. Existing members are considered during mesh generation, and plates are divided along that line to establish proper connection. Also, we can add any region with separate thickness or a hole. Say we want to add two shear wall in this model in these two panels. if we use the traditional approach, we have to be very cautious so that each new plate has a proper connection with the existing mesh. Else, there will be several plate-to-plate connectivity problem and analysis result will be erroneous. Using parametric model, we can simply define the boundary of the wall, then provide type of surface and meshing type. By the way, for shear wall design in advanced concrete design module, we need to model it using parametric model, else design will not be performed. During mesh generation, boundary lines are internally optimized considering existing beam, plate and node. We can further change the meshing size to make it finer or coarser. And once we are satisfied, finalize the mesh. Check the meshing quality. It looks fine. With proper connection with the existing slab mesh, with beams at different level, we can cross-check the connectivity using beam-to-plate or plate-to-plate connectivity tool. I have already discussed about all these methods of mesh generation in my YouTube series on FEM, including a detailed discussion on parametric model. You can check that series for more details. In older version of STAAD, there were several problems with parametric model, including performance issue and quality of generated mesh. All those problems have been fixed, and if we use this option in update 11, generated plates will be more accurate, optimized, and without any connectivity issue. This is a major improvement, and if you work with FEM more frequently, then you can try this version. Apart from this, there are few other improvements. First one is related to the mirror option. When you use this option to copy or move a part of the structure, existing self weight assigned to the original structure is also copied. And if this member orientation is selected, then proper beta angle is automatically calculated and assigned to the members. For example, consider this frame with tapered member. Beta angle is assigned to the purlins to align this along the roof panel. We can select this structure including the purlin and use mirror to copy the members including member orientation about YZ plane. See? All the member orientation are copied and beta angles are correctly assigned to the purlins. This is a new improvement. Similarly, for merging of multiple members into a single one, assigned release, beta angle, and load orientation are now copied to the new member. By the way, do you know there is an option available in STAAD to generate collinear member? We can select multiple collinear nodes and use this option to generate connected members. This logic has been refined in update 11. There are several other improvements and fixes in the analytical modeler, including section view in the UI and member query box. You can check this from the revision history file. One final update related to the moving load. In V8i version, vehicle information was displayed in the UI using a red diagram, which was not present in the CONNECT edition. In update 11, this has been reintroduced, and if we add a moving load case with proper wheel distance and load, initial position of the vehicle is reported using a red line. Using this, we can easily cross-check the initial position of the moving load and axle information. There is no major fix or enhancement in the physical modeler, only few minor improvements like graphical display of wind load with negative height. For OpenSTAAD, there are several major enhancements as well as bug fix, and if you are using OpenSTAAD function to generate any custom tool, few of these might be important to you. Till update 10, it was not possible to extract still design result using OpenSTAAD, and we can only extract the critical design ratio. In update 11, 9 functions have been included using which we can extract still design result including ratio, critical section and clause, force, and many more. For example, consider this model. I have designed this PEB warehouse using IS 800-2007 and I want to extract the design result for these few members. I have developed a custom tool for this. using these new functions. Here, we can use the selected members or provide any group name and extract all the design result in a single click. Easy, right? From this design result table, we can easily cross-check the ratio, clause or reason of failure, and accordingly modify the structure. If there are multiple design blocks, like one set of parameter for strain check and another one for deflection check, then also we can extract the design result of each block separately. We can check the individual ratio for strength and serviceability, and maximum ratio considering most critical condition, though this is now limited to AISC 36016. Apart from this, several new functions are added to the library to generate a new view of the structure, to merge, split or intersect certain members. Several useful functions which were not working properly, like function to add autoload combination, have been updated. Also, there are several problems in the help manual, like incomplete, incorrect or missing information. Most of these problems have been fixed now. If you are using OpenSTAAD function along with STAAD, then I'll recommend this version. Finally, I want to discuss about the updates in the integrated module. There are few minor updates in the steel autoadapter and section widget. None of these are important, so we can skip this. Along with this updated STAAD, latest version of Advanced Concrete Design, ramp connection and STAAD Foundation modules are installed. Build numbers are mentioned here. If you use any of this module in your project, then you can notice several new features like in ramp connection, new tubular connection for Australian and New Zealand code, truss gusset branch connection for Canadian and Euro code, or column cap connection for Australian, Canadian and New Zealand code is implemented. Along with that, several features of integrated connection design module, including detection of joint, have been improved. RCDC module now supports update beam design feature to generate STAAD file with updated dimension, and different steel grade for main and secondary reinforcement of column. For STAAD Foundation, wind and seismic load generation as per PIP code and combined foundation design as per 2019 edition of Canadian code has been implemented. All these modules are automatically updated during installation of STAAD.Pro Update 11. That's all about updates of CONNECT Edition Update 11. More information is available in the revision history file. Link is also provided in the news feed. If you are using any older version of STAAD and want to upgrade to this version, either download the setup file from software download page or update directly from the connection client. If a newer version than the installed one is available for download, it is reported in the connection client window. From here, we can check the updates, select and directly install it. I prefer this method as the existing version is automatically updated along with other integrated modules like STAAD Foundation and RCDC. Required setup files are downloaded during this process, so a good internet connection and full admin right is required. After installation, we only need to restore the customized user settings like quick access or quick commands toolbar, custom color and design code setting. That's all for today. Thanks for watching.